Up here. Okay, so hi guys. Today we are going to go over some of your probability questions for the performance final. I am here with my 6th period class. Hi everyone. Yay. And there's a little bit of lag for you guys here from what I'm speaking and what comes up on the screen, but we're going to go over the questions that you need to be prepared for the performance final. So you should take a look and let's go ahead and start our questions. So the first question says, a reporter has asked 150 voters if they plan to vote for a new library and a new arena. The table shows the results. So up here we have library, down here we have our arena, and then for each we have yes and no. Okay, so that's kind of how it all meshes together. So the question is, given that a voter plans to vote no for the library, what is the probability that they will also vote no for the arena? So the main word here that's most important is the word no. Given, and specifically given and no for the library. The reason why the word given is so important is because it now limits questions we're looking at. So much for that. So here it says given, they vote no for the library. So the only thing I'm going to look at is my library category. And not only my library category, specifically the library category where it says no. So if I look, that is only a total of 72 people. So on your papers, you should be looking at your table, and let's just add all the numbers going down. We've got 72 were library no. We have 78 that were library yes. If we add across, we get 51 and we get 99. So we can see that altogether that's 150 people, because if I add down 51 plus 99, that's going to give me 150. And if I add across 78 and 72, that also gives me 150. So I know that my sums are correct because I have the 150. So again, because it says given that a voter plans to vote no, I'm not caring about the 150 people, because if a person voted yes for the library, they're not part of my question or my study. So I have to look, how many people voted no? Anyone? Go for it. How many people voted no for the library? 72, right? So here's the library. 72 total people voted no. So 72 will go in my denominator because 72 people voted no for the library. But now it wants to know the probability. And it's what is the probability that they also voted no for the arena? So now I'm going back to my table and I'm looking at arena and I'm looking at where did they, vote no for the arena. Yep. So here's the arena, here's no. So at 42, they also voted no. So I'm going to put 42 in my numerator. So I have 42 divided by 72. So typically speaking, when we do that, we'll put it into a decimal. So all you do is you do the divide sign on your calculator. 742 divided by 72 is going to give you 0.52 or 58. Okay. Now it says what percent, so I'm going to leave that there, but I'm going to erase all this other stuff I wrote on it. What percent of the voters plan to vote no for both a new library and a new arena? Because there's no word that is given, nothing in that said given, I'm going to be looking at total number of persons. So the total number of persons is 150. So that's going to be on my denominator because there were 150 people who were polled. But then it says voted no for both. So does anyone have an idea of how many people voted no for both? 42. Okay, so here's no arena. Here's no library. And so 72 voted no for the library, but 42 voted no for both of them. So it's going to be our formula will be 42 over, change colors, 42 over 150. So if I do that on the calculator, I get 0.28. So do you notice the difference between these two things? Okay, let's take a look. So if we look over here.
Wouldn't it be 72 because it says for both the new library and
Nope. Because 72 only represents the people who said no in the library. If we look here again, when we go here, let me erase this. We good? Okay, so this first question said, given that they plan to vote no for the library. So because of that, we only cared about the people who voted no for the library. And in that section, we only cared about the people who also voted no for the arena. In this bottom one, we don't care if they voted yes or no for the library first. We just want to know the total. And that's why the second one is over 150 and the first one's over 72. Okay, let's go on to the next set. Okay, so now we have, given that a voter who plans to vote yes for the arena, what is the probability they will vote no for the library? So that's the same thing. We're going to go back up here and we're going to look at, okay, they had to have voted yes for the arena. When I go here, highlight tool, in order for them to vote yes for the arena, these are the only numbers that I care about right here. And when we added those numbers up, what did we get, everyone? Yeah, 51. So my denominator is going to be 51 because that's the only people I care about. I only care about the 51 people. Why am I using the mouse again? I only cared about the 51 people who voted yes for the arena. So given that the person votes yes for the arena, so that comes down here, what is the probability they vote no for the library? So how many people in what I highlighted yellow voted no? 30, exactly. So we have the number on the bottom changes because of that word given. That's what matters. Okay. Let's try to do the next one. What is the probability that a randomly selected voter will vote yes for a new library given that they vote yes for a new arena? Okay, again, there's the word given. Because of the word given, I'm only caring about yes for the new arena. So here's my yes for the new arena. Okay, and I want yes for the new library. So that'll give me my 21 over 51. Okay, let's see if we can get the rest of this page done. Was that too fast? Are we good so far? Okay. The owner of Pappy's Perfect Pizza wants to know which one of his locations has a better record for on-time deliveries. He collects data for 250 deliveries made one weekend. His downtown location has 75 out of 132 and his midtown. So first thing we're going to do is we're going to write midtown here. And then you're going to have downtown here. Then we either have deliveries that are on time or you have deliveries that are late. So write this down on your paper. So if Midtown had 69 were made on time, how would I figure how many were not made on time? Yeah, 118 minus 69, 49. If downtown had 75 that were on time, I'm going to do 132 minus 75, and that's going to give me my 57. Okay, so I know that this is 132. I know this is 118. And then going across, I have 69 plus 75 is 144. And 49 plus 57 gives me my 106. So now that you have that information, you can go ahead and plug that stuff in. All right, so I'm going to stop the broadcast now because I know y'all are going to pack up to leave.